We are proud to present Trayer's new high-speed auto transfer system. Trayer uses a vacuum fault interrupter with a 12.5 Ka symmetrical and a 20 Ka asymmetrical fault interrupting rating for use on 15.5 or 27 kV systems at 600 amps continuous. You will notice the mechanisms shown in the video are very similar to Trayer's load break switch mechanisms. They use time-proven technology and achieve the rugged reliability demanded of all Trayer products. As the animation begins, you can see we have a source 1, the preferred source, a source 2, the alternate source, and the customer or load. First, we have source 1 power available. This is shown by the elbows and cables becoming highlighted in yellow. Then source 2 power available. This is shown by the elbows and cables becoming highlighted in green. Next, the source 1 mechanism handle moves downward toward the tank to load the mechanism ready to trip closed. This is followed by the source 2 mechanism handle moving downward toward the tank to load that mechanism in the ready to trip closed position. Note, all switch handle operations can be performed manually or by the use of motor operators. Then the auto transfer controller will trip the source 1 unit closed. Now we have power feeding the customer from source 1. We have 6 voltage sensors connected to the incoming bushings. They measure the voltage on source 1 and source 2 on all 3 phases. Since these are analog devices, the customer has the ability to set the thresholds where the transfer will begin. The thresholds can be set at any percentage of normal system voltage. It's all customer selectable. When the system voltage drops below the threshold, the transfer sequence begins. The transfer controller processes all critical data from various inputs. Is there voltage available on the alternate source? Is it above the threshold? Is there a load side fault? With all requirements satisfied, the system transfers from the preferred source to the alternate source. The auto transfer controller, set in the return mode, will transfer back to the preferred source only after the source 1 mechanism has been reset and the full line voltage has been restored. The system return transfer is controlled by the parameters that are set by the customer. In our animation, we have set the return to take place at midnight, but only if the preferred source has been restored for a minimum of 5 minutes. The hour of midnight was chosen for a customer whose system would be lightly loaded at that hour, and the return transfer would be least disruptive.